Hello everyone, welcome to this lecture. We will be talking about domain specific example for embedded system, and here we are dealing with automotive. So the things you have to talk about is there are 4.2.1, 4.2.2, 4.2.3, but like just ignore the 4.2.3 part. In the 4.2.1 part, we will be talking about two types of ECUs, electronic control units, and 4.2.2 also consists of automotive communication buses and key players of the automotive embedded market. Mostly the key players of automotive embedded market. I don't think so. The VTU will or should ask this question. It's like mind irritating. Talking about the buses, they are communication buses. There are three over here. So we'll start with the inner working of an automotive embedded system through the exam helper notes. So here, the major application domains of embedded system includes consumer electronics, industrial, automotive, and telecom sectors. Automotive and telecom sectors represent a significant market share for embedded systems. Automotive embedded systems are electronic control units. See, you have to remember these things are nothing but they are the ECUs that control various mechanical and electrical components of a vehicle. Mechanical and electrical components of a vehicle. I just remember from this talking about inner workings of first automotive and system. Nothing but what they are just electronic control units which control the mechanical and electronic electrical components of a vehicle. Major applications are what you can talk about this same thing: consumer electronics, automotive, industrial, and telecom, which are the telecom and automotive are like bigger things. So this is basically about the introduction for the domain specific applications. Then you have to talk about the inner working of automotive embedded systems. They range from simple controls to complex safety systems. Simple controls are nothing but based on your comfort while driving, how you use your bag, seat, that arrangement, front and back, and other like windows, AC, that mirror, glass wiper, and everything like that. Complex safety systems is like airbags, this anti-lock brake systems, your gears, engine control unit, electrical throttle, and etc. etc. So the number of ECUs varies. In ordinary vehicles are 20 to 40, and in luxury vehicles are more than 100. The main one key point you can remember is the first automotive embedded system was microprocessor based fuel injection system introduced by Volkswagen 1600 in 1962. Sorry, 1968. So there are types of electronic control units. There are two types. One is high speed, and another one is low speed. Very simple, right? High speed is what used for critical control applications and requires fast response. Low speed is the opposite, less response time and is less critical. Built around low cost, and for this you can add a high cost. Example used: fuel injection system, ABS, engine control, steering control, central control unit, transmission control, and electronic throttle. Whereas talking about low speed, it's just like almost all comfort. See, audio controllers, door locks, power window controls. Power window control is something but that normal windows which you would like do up and down, right? Which are in the doors. That one. Wiper control, mirror control is nothing but your rear view mirror, back view mirror. That one. Seat control system, headlight and tail lamp control, sunroof control units. Now, if you just remember few points from this, if you add it up, it should be like 15 to 16, and you can simply write the same thing in that. Oh, sorry, it's my notes, right? It doesn't have diagrams. You can write the same thing in the diagram. See, it's more than enough. Suspension control will come in middle, like your car's spring type thing, up and down, and etc. like that. Mm. This is a small summary. What are they? They are specialized control units in embedded system vehicle performing everything from simple to critical safety functions. The complexity of number of issues you have to take varies, have increased over time. Classified by their response time. How they are classified? Based on the response time, high speed and low speed. What are they? Two are there. See, high speed are for safety critical, time sensitive control, and low speed are for convenience and comfort features. These are some potential exam questions which might be asked and quiz. I'll tell the answers while I'm reading, but when you download the notes, you have to do it by yourself, or just now, just do it by yourself and see out what's the correct answer. What does ECU stands for in automotive embedded system? That's electronic control unit. See here, unity is a, electronic car is a. Obviously, this is the correct one. A. This is the following is not a typical high-speed ECU. See, fuel injection system. It's very critical system. Anti-lock critical. Transmission control is critical. Door lock is not a critical. It's just convenience and the comfort base. So this is the thing. Is used in a luxury that is over 100. The first ever automotive, so historical note, it was 1968. Okay, automotive communication buses. So this is 4.2.2. Overview: automotive event systems are serial communication buses. Sorry, use serial communication buses to reduce wiring complexity inside vehicles. So usually serial in the sense like like one line will go like this. Serial or serial like in parallel in the sense too many connections will be there. Several types of serial interface buses are deployed in automotive applications, each suited for different requirements. 4.2.2.1. So like there are three, right? So all the three is explained one by one. By whom it was developed? See, Robert Bosch, a pioneer in automotive embedded system solutions. Sorry, embedded solutions. They're talking about speed. They're talking about protocol and application of it. See, controller area network nothing but CAN. Speed is medium speed or high speed. ISO 11519 class B up to 125 kb. Just remember this 125 kbps and class B is just mentioned that class C 1 mbps. Protocol event driven supports error handling in data transmission. Okay. Application safety system airbag control. See, that's a safety system. A powertrain system, that is engine control and ABS. Navigation system, GPS. Why I'm highlighting the example and not these actual headings, because you will it's easier to understand. I mean, remember examples. Through the see, airbag is safety, GPS is navigation. Just for engine control, you can remember this power system, powertrain system. Okay, we'll move on to the next. Local interconnect network, LIN. Bus type single master, multiple slave, up to 16 slave nodes. Slave. Wow. A low speed up to just 20 kbps. Here it was how much? 125 and 1 mbps. Two are there. One is medium speed and one is high speed. And this is low speed. So all the types of low, medium, high are covered in this two itself. Physical layer, single wire communication interface, communication, master trigger communication to avoid bus arbitration conflicts. Application, mirror controls, fan controls, seat position control, window controls, and it's mostly about the positions of all the things which you can do in car, like mirror, even the glass thing, windows, also the seat and the AC, that fan that controls and all. Mostly all about positions in this. Media oriented system transport, most bus. High bandwidth multimedia networking in vehicles, example audio video infotainment, primarily used in European cars. Network type fiber optic point to point network, supports star, ring and daisy chain. See, usually this is a star, right? See, wow, it came so nice. Daisy chain, nothing but you have to join this like I won't ruin that star. It looks so good. So you just connect this here, like it should come here, okay, like that. So, specification include physical layer, application layer, network layer, media access control layer. Oh, these are all the stuff you study in fifth, you know, computer networks subject in fifth semester. Pretty annoying, but you have to remember all those things. Summary about them. Who proposed a CAN bus? Yeah, the Bosch guy. What is the maximum data rate supported by CAN high speed at 1 Mbps? How many slaves? 16. Most bus uses which type of communication medium? Copper wires, wire, optical fibers. Most buses you don't go like most of the buses. This is that. What is media orientated dash? You know something ST. What's the ST? I forgot. System transport. Okay, that's it. Completed. Now we'll move to the next chapter. If you see the syllabus, we have completed these two things. The next chapter contains these two part. I'm gonna explain only till here. Hardware and software code design. Not gonna do this because I'm gonna just leave that when it's asked in the examination.